All right, so on to these first few examples. Let's look at examples 1, 2, and 3. Basically right here, again, we're going to take this trinomial and we're going to try to factor it into two binomials. Okay, so that's kind of where I start with. Just memorize if it's a trinomial, if it's 3 terms, 1, 2, 3, you're going to factor it back into two binomials. Now remember, you do your 4 multiplications with two binomials, but you're going to get 3 terms because your middle terms here, your outsides and your insides, they add to this 9. So when you do this, basically you're going to look to see whatever letters there in the middle or whatever letters squared in the first here, and that's going to go in your first places. Because remember, your n times n always has to be that n squared. Now we're going to ignore this 9n for just a second. We're going to look at the 20 because our last term right here, when we got to the c, our last term, our numbers have to multiply to c. So our numbers, we know, have to multiply to 20. So some of you guys are just going to be able to see these numbers right off the bat. I would still suggest us writing down all of our factors of 20. Okay, I'm not going to give you a factor chart. You're just going to need to learn how to make your own factor chart. I always start with 1. 20 could be written as 1 times 20. Then I just try and divide it by 2. It does divide by 2. 20 divides by 2. It's 2 times 10. Then I try 3. Problem is 20 divided by 3 is not a even number. It's a decimal. Try 4. 4 times 5 gives me 20. And this is nice. When your numbers are next to each other, you know you're done. Because after you try 4, you would try 5, and you're back to a number that's on your list. So you're done. Those are the only factors of our 20 right there. Okay, so our two numbers, our two integers, I should say, have to multiply to c. Now notice I've got 3 options here. There's 3 types of numbers that multiply to 20. That's why they give you a second stipulation. They also have to add to your middle number, to this 9 number right here. So they've got to multiply to your last number and add to the middle number. So you just go through and check. Does 1 plus 20 equal 9? No, cross that out. Does 2 plus 10 equal 9? No, cross that out. Luckily, our last two, 4 plus 5, gives me that 9. So we're just going to fill in a 4 and a 5. Kind of look at the signs. Again, if they multiply to give you a positive 20, they're both going to be the same sign, but when they add to give you a positive 9, they'll both be positives right there. Okay, this is your answer. And again, if you wanted to check these, that would be fantastic. That would be my suggestion. When you distribute your n times n gives you n squared, n times 5 gives you 5n. You're saying, well, why is it 9n? Because you've got another 4n. So you have that 5n plus 4n. That'll give you the 9n. And then 4 times 5 gives you the 20. So that is correct. We've done it. All right, let's look right here. Again, you've got a trinomial, 1, 2, 3 terms. You're going to turn it into two binomials. Okay, the easiest one to write down is the value or the variable that goes in this first place. Notice we've got a g squared and a g term, so they're going to both be g's right here. G times g gives you the g squared. Again, I kind of ignore this 1g, that coefficient right there. So b right here in this case is 1. I'm going to look at this -6 as my c. And I'm going to write down all my factors of 6. I know 1 and 6 multiplies to 6. Then I try 2, 2 and 3, and those are my only factors of 6 because we're back to 3. Okay, so now this time, notice that my c here is a negative. I'm trying to find two numbers that multiply to a negative number. Now that only happens if one of the numbers is positive and one of the numbers is negative. Okay, that's the only way that it works. If they are both positive, they'd multiply to a positive. If they're both negative, they'd multiply to a negative. But there's going to be one of each sign right here, which also means that it's a subtract problem instead of an add problem. When you add a negative number, you're really subtracting. So now instead of truly finding numbers that add to 1, you're going to find numbers that subtract. When you add that negative number, it subtracts to 1. So I just do 6 subtract 1, that's 5. It's not that one, but this 2 and 3, when I have 3 subtract 2, that gives me 1. So now look at this sign. Just make sure that when you combine these numbers right here, you've got to have a positive 1. So you want your bigger number to be positive. So you're going to put that 3 with the positive sign, with the add sign, and a 2 with the negative. That way, when you go to check it, you've got your g times g, gives you your g squared, g times -2, I've got -2g, but I've got a plus 3g, so -2 plus 3 gives you that 1g, which is what we want, and then 3 times -2 gives me my -6. So we are finished. We're done with that problem. All right, let's try a few more of these. Let's look here. Oops, that was the same color I just did. Let's try a sky blue. Okay, so we've got a trinomial, 1, 2, 3 terms. We're going to turn this into 2 binomials right here. So again, I look at my variable. It's going to be an x. X goes in the first places right there. And then I'm going to next factor my c term, my last term right here. I'm going to factor that. So we're going to look for all the numbers that multiply to 30. There's a lot of these. So I know 1 and 30 is where I always start with the ones. Then I tried 2. Can you divide 30 by 2? Yes, it's an even number. So 2 and 15. Then try 3. 3 and 10. Then try 4. 4 doesn't work, but 5 does. 5 times 6. And then once you're back to where you were, 6, then you're done. There's 4 different ways we can multiply numbers together and get 30. Okay, but remember, we know that not only do our numbers have to multiply to this -30 to the c, but they've also got to add to our b term. They've got to add to that -7. Okay, they are going to be different signs. Notice they've got to multiply to a negative. You're going to have a positive and a negative here. So they're going to multiply to a negative number. It's also going to be a subtract. We're looking for 2 numbers that subtract to 7. So 30 subtract 1, not 7. 15 subtract 2, not 7. 10 subtract 3, is 7. Okay, so 10 and 3 are my numbers. This time, look, I want them to combine to a -7. Okay, so your bigger number has got to be whatever that sign is. So since my number is negative, I want that 10 over here to be with a negative, and then I've got a +3. So when I check this, x times x gives me my x squared. -10x plus 3x will give me that -7x. And then I've got a -30 right there. Okay. All right. We'll do the next 3 examples in our next video.